Inside the world's biggest aircraft ever built, the Colossus of the skies. What if we told you there's an aircraft so massive it makes even the largest commercial airliners look like toys? With wings wider than a football field, engines strong enough to launch a small building, and a body that can carry spacecraft, this is not your average airplane. Welcome to the world of the Stratolaunch Roc, the largest aircraft by Wingspan ever built. A 6-engine, twin-fuselage flying behemoth designed to launch rockets into space from the sky. In this video, we're diving deep into the engineering marvel, the incredible story behind its creation, and the jaw-dropping missions this giant was built for. So buckle up, because we're flying straight into the heart of the world's biggest aircraft ever built. Bigger than anything else that's flown. Let's get one thing straight. When we say biggest aircraft, we mean it. The Stratolaunch Roc holds the record for the largest wingspan of any aircraft in history, 385 feet. That's wider than a US football field, and 100 feet wider than a Boeing 747. It's even bigger than the legendary Antonov An-225 Mriya, the previous heavyweight king of the skies. While the An-225 was longer and heavier, Roc takes the crown for wingspan, a critical dimension for its unique mission. The aircraft weighs about 500,000 pounds when empty, but when fully loaded with fuel and payloads, it can exceed 1.2 million pounds. Let that sink in. A plane heavier than 3 fully loaded 747s, flying high above the Earth at 35,000 feet. The dual-body design. Why 2 fuselages? One look at the Stratolaunch Roc and you'll know this isn't your average plane. With 2 fuselages connected by a giant central wing, it looks like something out of a sci-fi movie. But this twin fuselage design isn't just for show. Each fuselage has its own cockpit, but only the right side cockpit is active for piloting. The left side is essentially a giant structure to balance the aircraft and carry support systems. The payload, like rockets or hypersonic test vehicles, is mounted in the center wing section between the 2 fuselages. This gives Roc a unique advantage. It can carry and launch massive payloads mid-air, without interfering with the aircraft's main body or engines. The rocket launcher in the sky. So why build something this massive? Because Stratolaunch was designed with a specific mission, air-launching rockets into space. By flying rockets to high altitudes and then launching them from the air, the Roc bypasses the need for expensive ground infrastructure and avoids bad weather and traffic at crowded launch sites. This also allows for quicker, more flexible launches with reduced fuel needs, because you're already above much of Earth's dense atmosphere when ignition begins. At first, Roc was meant to launch Orbital ATK's Pegasus XL rockets. But after the death of Microsoft co-founder and Stratolaunch visionary Paul Allen, the mission changed. Today, the aircraft is being used to launch hypersonic test vehicles, including Stratolaunch's own Talon-A, a cutting-edge reusable spaceplane. Under the hood, the engines of Titans. Powering this beast are 6 Pratt & Whitney PW4056 engines, the same ones used on Boeing 747s. Each engine produces 56,750 pounds of thrust, combining for a total thrust of over 340,000 pounds. That's enough to get this behemoth airborne and keep it cruising at 35,000 feet. And those engines don't just push a big plane, they also need to lift massive payloads, maintain precise flight paths for rocket launches, and provide redundancy in case of engine failure, all while being attached to a custom wing longer than a blue whale. Giant landing gear for a giant plane. Of course, a plane this big needs a monstrous set of landing gear. Roc uses 28 wheels, yes, 28, spread across its 2 fuselages and wing roots to distribute its colossal weight. The wheels were adapted from the Boeing 747 as well, but heavily modified to support Roc's unique twin-body structure and high takeoff weight. Landing something this huge takes multiple pilots, precision avionics, and a runway over 12,000 feet long. You don't just fly Roc into any airport. You land it at facilities like Mojave Air and Spaceport, the kind built for rocket planes and space shuttles. Built from 747 DNA, but entirely custom. Although the Roc looks like a Frankenstein 747 at first glance, it's actually a completely custom build, just using 747 parts where possible. The cockpit, engines, landing gear, and avionics are derived from Boeing's classic jumbo jet. But everything else? custom composite structures, special fuel systems, and advanced telemetry design to handle the unique stresses of mid-air launches. The central wing, the widest ever built, is a carbon fiber composite marvel, strong enough to carry a 500,000-pound rocket without snapping like a twig. This wasn't just an oversized commercial jet. It's an entirely new breed of aircraft, built from scratch in the Mojave Desert. The man behind the monster, Paul Allen. None of this would exist without Paul Allen, the billionaire co-founder of Microsoft and passionate space visionary. Allen believed in using private innovation to open access to space. And after co-founding the Spaceship One project, which won the $10 million Ansari X Prize, he turned his eyes to something even bolder. Stratolaunch was his ultimate bet on the future. He wanted to build a platform that could launch rockets, satellites, and reusable spaceplanes on demand, anywhere, anytime. Sadly, Paul Allen passed away in 2018, just months before Roc's first flight. But his vision lives on in every wing beat of this sky titan. First flight. History made in the desert. On April 13, 2019, history was made. The Stratolaunch Roc took off from Mojave Air and Spaceport, soaring gracefully through the California sky for 2.5 hours, reaching an altitude of 17,000 feet and a speed of 189 miles per hour. It wasn't about speed, it was about control, stability, and proving this giant could actually fly. Since then, Roc has completed multiple test flights, gradually increasing altitude and complexity. Today, it regularly flies with hypersonic test payloads for both Stratolaunch and U.S. defense programs. The future, from space to hypersonic dominance. While the original mission was space launch, the Roc has since evolved into something even more exciting, a hypersonic test platform. Stratolaunch now develops and launches its own Talon-A hypersonic vehicles, capable of reaching Mach 5 and beyond, from Roc's central wing pylon. The idea? Provide a reusable, affordable testbed for the hypersonic race, something the US military, DARPA, and even NASA are extremely interested in. This makes the Roc not just the largest plane in the world, but potentially the most strategically important one for America's high-speed future. A legacy beyond size. The Stratolaunch Roc isn't just about breaking records. It's about breaking limits in design, in space access, in hypersonic tech. From its wild twin-fuselage structure to its massive wing to its potential to reshape future warfare and space exploration, Roc is a triumph of engineering vision. Let us know in the comments, and don't forget to like, subscribe, and stay tuned for more captivating content on our YouTube channel.